Alright, now let's look at a different example. Okay, I believe that most of you have seen Star Wars, right? So you guys probably have seen this object before, so I hope you know what it is. Now suppose you want to do the same thing, right? It means you want to build some kind of a space war simulation in Python. Now how would you do this? Well, the first thing we want to do is to think about what kinds of objects we want, right? So in this world, there are obviously ships. These are not the kinds that float on water. These are spaceships, right? And then there are also space stations. You know, the one you saw in the earlier picture is this Death Star, okay, a very nasty space station. And there are also other objects that could potentially be in this world. So think about what they are. After thinking of what sorts of objects could be useful, you can also think of particular objects. For example, like this Enterprise. What is Enterprise? Well, the Enterprise is from Star Trek, and it's a particular spaceship, right? And it's also a Millennium Falcon. Okay, I know this is not very kosher. You're mixing Star Trek and Star Wars. Millennium Falcon is the spaceship that is flown by Han Solo in Star Wars, right? And the Death Star, this comes from Star Wars, right? It's the evil thing that Evil Emperor built. Okay, so let's see how we would start to define these objects, right? So first we start with the ship object, and we initialize the object here. All right, again, this is the self pointer, right? This one's, okay. Just note that every single one of these definitions will start with the self pointer here, right? This P is the position of the ship. Okay, V is the velocity of the ship. NamedObject, number of torpedoes in the ship. So the ship has got position, velocity, and torpedoes. Now, what can you do? You can move the ship, right? And so you set the position to something else. Okay, you figure out how to set this, right? Now, you can also fire torpedoes, right? If you have some torpedoes, you fire, whatever, right? So this, for example, you can imagine to be the beginning definition of a ship class. Objects have two things in general, the state and the methods that will apply on the objects, right? So in the Starship example, the state will be position, velocity, and number of torpedoes, right? You need to keep track of the position, the velocity, as well as how many torpedoes it has, right? Methods, move, attack, whatever, right? So if the Enterprise, okay, is a ship and it's here and it's traveling at this velocity, has 3 torpedoes, and the Falcon, right, is another ship over here at this velocity with 8 torpedoes, right? Then if you go and print Enterprise, you will find that it's a ship object. You print Falcon, it's a ship object. And these two are different. Okay, these are like memory addresses, and they are different addresses, so they're different objects. Next, we can have space stations. And again, space stations, you init and the position. There's no velocity because you can't move too much, right? And this position. And you can attack, right? You can attack, fire, death, ray, whatever. Now, we can also have torpedoes. Torpedoes, similarly, you can have P and V, is position and velocity. You can also move, you can also explode, right? And if you explode, it goes off. Now, it turns out that there are some interesting observations you can make. First is that this is the ship, right? The ship has got 3 variables, or 3 state variables, position, velocity, and torpedoes. Has got 2 methods, move and attack, right? And the torpedo similarly has got position, velocity, and it's two methods, move and attack as well. So you notice something interesting, right? You notice that these two, okay, are the same. These two are the same. You go, that's interesting. You suddenly realize that there's some common parts. So you can take out the common parts or abstract it out as a mobile object. So now you see this mobile object here. You see position, velocity, move, and attack. Now, torpedo, it turns out, is an instance of the mobile object. Okay, so basically, a torpedo is a sort of type of mobile object because it moves. And in addition to the move and attack, you can also explode. Now, similarly, a ship is also a mobile object, but it has extra torpedoes. Okay, and it turns out that there's a different attack, right? Because the way a torpedo attacks, the way a ship attacks is different. So if the torpedo attack uses this attack, then the ship needs to use a slightly different attack. So it contains its own attack method. So the general idea of inheritance is that we want to exploit the common structure, right, between objects in order to share code and to reuse code. So objects that exhibit similar behavior should all inherit from the same base object called the superclass. So in the earlier example, right, the mobile object is a superclass of both the ship and the torpedo. And similarly, an object that inherits from the superclass is called a subclass. So there's a super for the parent and a sub for the child. You can say that the subclass specializes the superclass by extending the state or adding extra behavior, right? And the classes has some kind of a hierarchy of relation, where it is a relation, and this establishes a natural sort of type hierarchy. Okay, when did you last see this? Well, if you remember, in missions 11 and 12, you did this number thing, right? So you have ordinal numbers, actually rational numbers, which are complex numbers, right? So that's a simple hierarchy of type. Now, next, we can have this idea of classes. Okay, so class defines what's common to all instances. It provides the state variables, it provides a message handler, and it also specifies what superclasses and what methods are inherited. Okay, the root class is something that is kind of at the root. So all user-defined classes should inherit from either a root class, okay, or some other subclass. Okay, let's take a look. So in this case, we have defined NamedObject to be sort of the root class of the system, and then it has a name, okay, as the only attribute. A MobileObject is a root, is a name object. It's got a location, it's got a place, and install, and some of these functions, right? Oops. And a ship basically is a type of MobileObject, and there's some more functions or methods. The root object in this system is the NamedObject class, but actually it is by itself a subclass of this object. Okay, so this is the root object of the Python object-oriented programming system, okay, OOP system. And right now what I do here is that I set the name to the name, right? So self is a pointer to the current instance, and name is input to this initial init function. So I set self.name, which is the variable name under the self object, to name. Okay. Now, as I mentioned before, the self variable is something that allows you to access an instance itself. So it's a kind of pointer, right? And pretty much it allows you to point to the current instance within this class definition. Okay, why do you need this self? Well, it turns out that when implementing a method, right, you sometimes need to ask the part yourself to do something, right? And sometimes you need to ask the whole object to do something. The reason why you need to use self is when you actually have what you call shadowing. That means the subclass has a method that's the same name as superclass. We will be talking about this in the REST station, okay, an example in REST station, so that should be fine. Now next, let's look at the MobileObject. MobileObject will inherit from the name object, right? And essentially it takes the name and the location, and it sets the name and location, okay, and it installs itself. You ask yourself to add thing yourself, okay, it installs itself into its current location. So location here is its current location, right? Do you notice it's not repeating code? Okay, for example, here you have this, okay, here you have this. So essentially this code, right, self.name and self.name, they are repeated, right? They're the same code. So let's think of a scenario. What happens if all of a sudden, right, you decide that all names must have lowercase? Well, basically what you need to do then is that when you create a new object and you get a name, and the name is not in lowercase, what you need to do is convert it to lowercase. Okay. Now, but if you want to do this, then manually you need to change all the declarations in all the methods in the whole class hierarchy that does this thing, right? So for example, right, you have these two parts, right? You have this thing here and this thing here, right? It means both of them you must change to name dot is lower, right? Otherwise, how? Well, it turns out you can do it this way, right? You can do super dot init name, right? And what happens that this would call the method here. So super will allow you to refer to the superclass object, which is now the name object. Now let's look at another example. You have ship MobileObject. So ship inherits from MobileObject, and here in the init method, you have called the init method of the MobileObject, passing in both the name and the birthplace. Right, and here you set other variables. Okay, the threshold is set to threshold. Okay, as a new input. It's alive, yeah, it's out of true, alive, install yourself. Okay, moving, how do you move? Basically, if you ask yourself, if your threshold is less than 0, you don't move, right? Just pass. Otherwise, what you do, you randomly pick between 0 and self.threshold. If this is equal to 0, you act. Okay, what's act? You look at yourself, right? And you look for a random neighbor, and this is a new location. Okay, and if this is not now, you will move to the new location. Right, so move to, if you're already at a new location, then you don't do anything, right? Otherwise, you print move from here, from the current location to the new location. You remove yourself from the current location, you add yourself to the new location, and you set your location to the new location. Okay, otherwise you cannot move. go. Okay, suppose you're going in a direction. You want to go to a certain direction. Basically, from your current location, okay, you check the neighbors towards the direction, and it's a new place. Okay, if this is not now, you move to the new place. Okay, otherwise you say you cannot go there. Shoot. Okay, so what is this? You filter lambda ship name is the ship name. Okay, self location dot things. So you look for all the things in the current location, right? You filter out all of them for which the lambda ship name is ship name equal to this input. Okay, and this are the target ships. If this thing is more than 0, that means there's more than one ship, then you take the first one, okay, and you fire it. Then once you fire the ship is destroyed. Alright, let's see how the ship is destroyed. When you destroy ship, right, you print a self-destroyed, set alive to be false, and you move to heaven, right? So you can create enterprise, right, as a ship, right, in the following way. You can put it on Earth, and you can have -1 for threshold, which means that the ship will not move by itself. Okay, so let's take a look at the bad guys, how we do it. So the bad guy is a new class of ships. It will fire at us, right? And so it's subclass. So EnemyShip is a ship, right? And it turns out that the EnemyShip will do it a bit differently. You will act, okay, in a different way. You will fire at you, right? And basically, instead of using this act, okay, you will now use this act. This thing is known as overriding. Basically, if you have a method in the subclass that has the same name as superclass, it's overriding. Okay, and this is a behavior is known as polymorphism, right? Basically, you have many different forms for the same thing. So let's take a look at how the EnemyShip will act now. So self.location things. So it checks for what are the things in the current location. It will filter out, okay, all the instances of things that are ships, right? So ships will be everything else that is current location. There are ships. Now you will filter out also ships that is yourself because you don't want to shoot yourself. Now if there are other ships, if there are no other ships in the vicinity, it means the length of other ships now, then you call the superclass to act. So essentially, if the enemy ship behaves like a normal ship, you will do a random number, you move around if there's no other ships. Now if the other ships, right, if the ship names this is not now, you will shoot at a random choice of ship. Okay, so let's take a look at how this thing will work.
Captain's log, stardate 45944.1. Following a magnetic wave survey of the Parvenian system, we have detected an object which we cannot immediately identify.
Okay, now let's take a look at how the space war simulation will work. You can go to spacewar.py and then you run it. Okay, and now you have this screen, right? So it says Enterprise is at Earth. You see Enterprise exits east, so you can go east. Okay, and then you go from Earth to space, right? And you're at space, and you can go north. Okay, whoops, you can go east. And we can go east. Alright, and we can go north. We're now in deeper space. We can go north. Okay, now we see that we are at black hole and we see Warbird, so we wait. Oh no, so Warbird fires Enterprise. Enterprise is destroyed. Oops, and now Enterprise moves from black hole to heaven. Okay, oops, I think we're gone. So let's try again. Okay, let's run the system again. Alright, so let's try again. Now Enterprise is at Earth. We go east. And we go north. And we go north. Well, it turns out the Warbird has moved from black hole to deeper space. And now we see Warbird, so we shoot Warbird. So Enterprise opens fires at Warbird. Warbird destroyed. Okay, Warbird moves from deeper space to heaven. How cool is that?